All right, so we're going to look at how we can draw piecewise functions by hand, and then we'll use a graphing program that you can find online to verify that our graphs are correct. Now, when graphing a piecewise function, sometimes students will just graph the two pieces of the functions and ignore the range over which, the domain over which each piece is defined. You can't really do that. If you plot x plus 4 and 2x minus 1 and just plot them like everywhere, like throw them in your calculator, you're going to get an x in this case. You're going to get just two lines plotted on top of each other for all x, all values of x. That is not a piecewise function. That's not even a function. So it's essential that we pay attention to the intervals on which our pieces are individually defined, because together they form a function. But if you just separately graph them, you have two functions. You don't have one function. So when we plot our pieces, we start by plotting at the endpoint, and then we pick another point on the function in order to draw the piece. For this particular piecewise function, since each piece is just a line, we can draw a line with 2 points. And so we need an endpoint and then one other point on the line on that section of the graph. So to plot x plus 4, we're going to start with x is equal to -1. So that's where the line ends. Now, because there's an equal sign on this value of x, we're going to draw in a closed circle to indicate that that point is included in that piece. And then we'll pick one other point also less than -1 that we can then use to connect the dots. So if I pick x equals -1 and I plug it into here, I'm going to get x is equal to 3, -1, 3. And again, I have to color in the closed dot. And then I pick another point, let's say x equals -2, plug that in, I get 2. And then I connect my dots, my closed dot, and then I continue my graph for values of x that are less than -1. And then for my second piece, I still have to plot the endpoint. I can't skip over to 0 because this section of the graph between -1 and 0 still has a graph on it. My piece here doesn't start at 0. It's not like all values are integers, not at all. So I have to plot -1. I have to, because I need to know where this function is going. It goes all the way up to, but not quite to -1. So when I plot this piece, I still have to plot it at -1, but I draw an open circle to indicate that I get really, 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 really close, but not exactly to that point. So if I plug -1 into this graph, then I'm going to get -2 minus 1 is -3. So -1, I get -3. And here I draw an open circle to indicate that I get to, but don't quite get to that point. And then I plug in another point on this interval. So something bigger than -1, like 0. And that will give me a point here. And then because it's a line, then I connect the dots. Forgive my straight line, not so very straight lines. And I get a graph that looks like this. The two endpoints have to line up right on top of each other in most piecewise graphs, but one will be an open circle and one will typically be a closed circle. Now, if we go then to a function, a website called Graph Free, we can actually draw the piecewise graph using technology and make sure that we have the right graph. So we're going to change the axes so that we can see a bit more of the graph, not just the first quadrant. And then I'm going to go to the first plot and I'm going to select piecewise, which will give me a bunch of pieces and places where I can put inequalities. So I had x plus 4 when x was less than or equal to -1, and I had 2x minus 1 when x was greater than -1. And so I can get this graph, and I'm going to copy it and go back to my other screen. And if I paste this here, just move this off to the side to do our comparison. And you can see, again, other than the scale of the graph, you can see that this intersection point is at +3. The circle is closed in. Our straight line goes out down to the left. And then I have an open circle here at -3, x equals -1. And then my straight line goes off at a different slope through the point -1, x equals 0, y equals -1. Now, for straight lines, you just need that endpoint and then one additional point. But if you have a non-straight line, then you need some additional points to plot. And so let's look at this one. This one has 3 sections of the graph, but both of the pieces that are not just a single point are curves. And so we will need to plot the endpoint when we can, that as an open circle. But then we will need to also plot more than 1 point on each, more than 2 points on each section. So this is going to still basically work the same way. So again, we can't just plot these individually and then ignore the inequalities. When x is less than 0, we're going to have this parabola. So we're going to plug in 0. And that's going to give us 1. But again, this is less than 0. So even though we plot 0, we're going to draw it with an open circle because we're going to get as close to 0, but not quite. And then we're going to plot a couple more points where x is less than 0. So let's say x is -1. I plug that in, I'm going to get 0. If I plug in -2, that's going to be 4. 1 minus 4 is -3 down here. And then I'm going to try to draw my parabola as well as I can with the mouse. That's not actually too bad. And then my second point is just 0 when x is 0, because this has an equal sign. I'm going to make it a closed circle. My mouse is being very uncooperative. And then for this one, this is when x is greater than 0. So I don't have to worry about that. I mean, there's an asymptote when x is 0, right? But if I plug in a bunch of points, I can't plug in 0 because it's an asymptote. But I can plug in several other points. When x is 1, I'm here. When x is 2, I'm here. 1/3, 1/4, and so forth. When x is 1/2, when x is 1/3, when x is 1/4, and so forth. And so again, I have this vertical asymptote, and then this nice curve, oops, which should of course end up being asymptotic to the x equals 0 line, or the y equals 0 line. So this is approximately what my graph looks like. And so we're going to go to graph free again, and we're going to take a look at what that looks like. And so we had 1 minus x squared when x was less than 0. And we had 0 when x was equal to 0. And 1 over x when x was greater than 0. Now we see actually 2 of these plotted okay. This one is our parabola. That's great. Here's our just x equals 0, y equals 0 point. The 1 over x is having a little bit of a problem plotting. If you run into this problem, then try adding some decimals so that it's not strictly 0. I think the algorithm is trying to plot 0 and it's getting undefined and so it doesn't know what to do. But if you plug in something that's really, really close to 0, then what will happen is the graph will actually function properly. It's a little bit of a quirk of this particular program, but you get that 1/x graph now. And so we can copy this and go back to our other graph and confirm that it didn't paste because I copied the wrong thing. Let's try that again. There we go. So there's our 1/x, there's our parabola, and there's our dot.